Hi, I'm Jason Moore, Director of the Institute for Biomedical Informatics at Penn Medicine. I'm going to introduce PennAI, an accessible artificial intelligence software tool for data analytics. Machine learning can be very challenging for a whole host of different reasons. First of all, it requires specialized knowledge and training. Second, there are numerous important decisions that need to be made about the machine learning algorithms to be used and their parameter settings. Software for machine learning is often not accessible or easy to use, and commercial software in particular is often not open or transparent. We live in a big data world, and machine learning is necessary for progress. We believe that everybody who wants to use machine learning should be able to do so, regardless of their training or expertise. This is how we think of the data science pipeline moving from left to right. We start with multiple different data types. We integrate those data into a data warehouse or database. The first thing we might want to do when working with big data is feature selection. In other words, selecting a subset of variables or features to be analyzed based on some criteria. We might want to construct or engineer new features. And then we need to pick a machine learning method to use and the parameter settings of the machine learning method. Once we've fit a model and we're happy with it, then we need to interpret it, we need to validate it, and finally, we want to be able to use it for clinical application with tasks such as clinical decision support. PennAI is designed to automate the middle part of this process, the machine learning methodology. PennAI is accessible and open artificial intelligence specifically for automating machine learning. The goal is to lower the barrier to machine learning by making it easy to use and by making it open and transparent. PennAI has been available since May of 2019, and the latest version is available on GitHub. PennAI will connect soon to other Penn Medicine resources such as PennTurbo. When you log into PennAI, you interact with it through a web interface, and this is what you see. Every square on this screen is a different data set. Data sets are loaded as CSV files through the PennAI interface. And from here, you can get a snapshot of the best performance and the best machine learning algorithm run on this data set thus far. For this appendicitis data set, you can see there are 46 different machine learning analyses that have been run, and this is the best one obtained so far. Now, the AI button makes it very simple to run machine learning on the data set. All you have to do is push this button, the computer takes over and launches what it thinks is the best machine learning algorithm and parameter settings for your particular data set. And it does this with a database of results that we turn into expert knowledge about machine learning, so the computer can be informed about the best machine learning method to run on your data set. So this makes PennAI super simple. You load a data set as a CSV file, you can push that button and the computer does the machine learning for you. Now you can do an interactive machine learning analysis by pushing the blue button. This takes you to the build new experiment screen where you can choose from a set of commonly used machine learning methods. When you select a method, you are presented with the different parameter settings. You can select those parameter settings interactively, push the launch experiment button, and the machine learning analysis will run on your computer or server. So this makes an interactive machine learning analysis by the user very easy. PennAI has a database of machine learning results that you can explore interactively, and from there, you can download the computer code, the Python code that generated the result, and you can get access to this dashboard, which summarizes lots of different results from the analysis. You can access PennAI in a self-service manner. You can download the code, install it on your own server or computer. This does require a little bit of expertise and some familiarity with Docker containers, which we use to build the PennAI software. We have our PennAI team available to assist you with the installation process if you would like. You can contact Heather Williams, or you can contact me and I'll put you in contact with somebody that can help you. You will need a server or a computer for the installation, and the type of computer depends on the size of the data or the number of users expected. If your data sets are on the smaller side, you could certainly run PennAI on a laptop or desktop computer. If the data sets are bigger or you have many users that will be accessing PennAI, you would want to work with PMax, for example, to set up a server that can handle the load. Here's a use case applying PennAI to real data. This is a paper that we published in Bioinformatics in 2020. We accessed a data set from the Mimic database, which is an electronic health record resource from Brigham and Women's Hospital. This database consists of about 60,000 ICU patients and their electronic health record data. And in this study, published in Scientific Reports, the authors developed a deep learning algorithm called a long short-term memory neural network to analyze this data to predict septic shock. We applied PennAI to these data. PennAI generated in this table a set of results along with user-generated results. And we show a comparison in the top part of the table of the PennAI results and the best result found by PennAI with the deep learning LSTM algorithm in the bottom part of the table and a tuned logistic regression model as a baseline. PennAI found a gradient boosting algorithm that tested, had a 0.85% testing accuracy on a holdout data set. And this was comparable to the deep learning algorithm. It was discovered automatically and ran in a fraction of the time. We plan in the next year to integrate PennAI with PennTurbo, which is a new resource coming online that there will be a video about for integrating clinical data and allowing self-service access through queries of the database. This will allow PennAI to have direct access to clinical data for analysis. We also plan to add some advanced machine learning methods for feature selection, feature engineering, and feature transformation in the coming year or two. I would like to acknowledge the PennAI development team. Wei-Shan Fu is a programmer. Dr. Bill LaCava is an informatician who developed the AI algorithm that PennAI uses. I serve as the project director. Michael Stauffer is a programmer that works on the interface for PennAI. And Heather Williams is the lead software engineer and really the architect of the PennAI software. Funding is provided by the Institute for Biomedical Informatics and the Clinical and Translational Science Award from ITMAT. You can contact Heather Williams or you can contact me, and those are our email addresses. Thank you.